Hi. Hi, Percona. My name is Renato. I'm a cloud architect. I'm a lazy cloud architect. I'm a cloud architect that doesn't like too much to have to manage production relational databases. And we'll see in a second why. Today, we are going to talk about serverless databases, serverless relational databases, what is good about them, what is bad about them, and the ugly bits. So before really starting to discuss serverless database, we have to first discuss what are the main main characteristics to define something like a relational database serverless. There are different ways you can define something serverless, but let's say there are four main characteristics that we all tend more or less to agree they are part of the deal. First of all, a database has to be highly available and fault tolerant. If it's not, it's hardly something that we'll put in the serverless paradigm. There should be, of course, no server maintenance. If I have to SSH to the box, patch my own operating system, patch the version, the database engine, well, probably that's not really serverless. I should be charged for usage. What does it mean? Well, the idea behind is I don't really want to pay when the database is not used. When there's no traffic, I don't want to pay for it. If the traffic doubles, I expect to pay more. If the traffic goes down, I expect to pay less. So I don't pay for peak users, but I pay for really what I use. Of course, then there's the storage layer, and that I pay for what I store. And as well, fourth key characteristic, I should have some kind of continuous scaling. What do I mean by continuous scaling? Well, the more traffic I have, the more my database will go up. The less traffic I have, the less my database will go, my database will probably go down, scale down. There's one tweet that is now probably 3 years old that I really find it very important to highlight what a serverless database is. Because first of all, we have to define what is not. The key point is serverless is not simply a function. Function as a service is, of course, function, but serverless is more a price point characteristic and on-demand scaling. So it can apply to function, but it is not really limited to function. With that in mind, because otherwise there's really no serverless database. Think about these four characteristics we had in mind. You might say, well, there are already databases out there, databases on the cloud that that cover those requirements. What? Well, if you think just AWS, Amazon has had for, I don't know how many years now, DynamoDB, almost 10 probably, that you could arguably say that it fulfilled those requirements. And as well, Azure has Cosmos DB, that has now as well a serverless option. Google Cloud Data Store is as well cover those characteristics, and as well for NetBeer, other solution can cover those characteristics as well. So what's the point? Why are we talking really about relational database? Why, for example, there's Aurora Serverless and other solutions out there? Well, reality is, when you think about relational database is often your bottleneck. Your bottleneck because you have your nice, beautiful, even on the cloud, relational database, MySQL running on a single server with a high running behind some application server that maybe scale horizontally according to the load, using AutoScaling, using Kubernetes, use whatever you want. But reality is that the backend scales usually in a much easier way than your database. It's much more elastic. So I said at the beginning I'm lazy. And when I take care of my cloud deployment, I would love that my cloud deployment scale according to the traffic as well, according to unexpected load, according to unexpected bugs, according to what the resources I really need. And that usually works quite well for the application layer, but it's much, much harder to achieve at the database layer. And well, when I'm out for a nice weekend on the mountains, I probably don't like that my Elastic application layer scales, but my database doesn't. So why don't I use one of the options we said at the beginning? There are already many solutions out there that cover those requirements to be elastic. Well, part of being lazy, I want as well to reuse the knowledge I have in the team. I want to reuse the product I have. I don't want to migrate to the cloud and say, okay, let's get rid of my SQL database and do everything in Dynamo. There are reasons, apart from lock-in, vendor lock-in, and other reasons as well. I don't want to reinvent everything I have. I don't want to migrate all the data I have. I want to reuse. So how can I use my relational database on the cloud and make it as elastic as possible? I love this slide. I love this tweet from Andy Jassy, the CEO of AWS, because at the end of 2018, almost 2 years ago now, he was very excited to let the world know that in his long-term battle with Oracle, almost the majority, 97% of their critical databases and 88% of their Oracle databases had already been migrated to Aurora or DynamoDB. And a few months later, actually 1 year later, they were able to say, yeah, task achieved. We are now fully on Aurora and Dynamo. Now, great achievement, but if you think about AWS, a company with almost unlimited resources that is trying to get out of Oracle as soon as possible, basically, and that has had Aurora for many years, has had Dynamo for many years, Aurora for more than 5, Dynamo even more. The fact that it took over all that time to even achieve that proves how hard it is to migrate your data, how hard it is to get out from one database to move to another one. So even say, oh yeah, cool, your application doesn't scale with your current relational database, let's use Dynamo, let's use something else. Well, cool, great, but maybe it's not that straightforward, it's not that easy to achieve. So what we really want is to really reuse, we're lazy, we want to use what we have, our relational database, and make it as elastic as possible. And try to achieve those 4 characteristics we had. At the end of the day, what we want is a database cluster that automatically scales up, shuts down when I don't use it, starts up when I start to use it, and has capacity based according to my application needs. And what's usually hard to achieve? Why is that hard to achieve that with relational database? Well, if you think about deploying your MySQL on the cloud or Postgres or whatever, connection limit, if you think about max connection, things like that, they don't scale so elastically. It's not that you can simply change it, keep changing and have it moving their limits and you have to take care of it. There are networking issues. You might have an elastic application layer in front, but if behind there's a single database server that at some point you saturate your networking, well, there's not much you can do. You can scale up to a point your application. There are as well provisioning issues. You might, when you think about doing it yourself, is how much storage I'm going to allocate, what kind of storage, how many read and write IOPS I need, and that's all cost, that's all that money. And I don't want to just provision everything for peak load or to relax for the weekend. I have as well scaling issue because, okay, you can do some vertical scaling, scaling up and down the size of your RDS of Aurora, but it's not immediate, it's not a few milliseconds operation, and you have to think about different metrics, how you're going to do it. It's not out of the box. And as well, there's the problem of infrastructure as a code. We want to version all our code, use Terraform, use CloudFormation if you use Amazon. And when you think about that, manage your relational database in that infrastructure, well, you can do it, but it's not the most obvious use case. So let's see how, for example, using MySQL and Postgres on AWS, which option we have and how we can get the 4 requirements we had at the beginning. Well, let's go quickly. Basically, there are 4 major options you can have to run your relational databases on at least MySQL on AWS or Postgres. First one is, of course, use a virtual machine or a container, whatever you want, but basically your root, you have install whatever you want, is you basically just you have the full flexibility, you have the full responsibility. Of course, there's no out-of-the-box failover, there's no out-of-the-box backup. You have to take care of yourself. Sometimes it's the only option. If you have specific requirement, you have a specific version of the engine you want to deploy. If you want to use Percona, you can do that. That one, entirely flexible. Flexibility is the main characteristic, but out of the 4 requirements, we haven't covered any of them. Well, RDS for MySQL has been there for 10 years through many different iterations, many new features, and the last few years as well, even the storage can scale up according to when there's no storage enough, it can automatically add some more storage, but some synchronous replication out of the box with multi-Z, but even in a stretch way, this is a managed solution, but even in a stretch way, you can say that Out of the 4 requirements we had, we probably covered 2. We definitely have an instance always running. So if we don't use it, we still pay for the instance. And as well, in terms of scaling, according to traffic, nothing there, nothing out of the box there. Aurora is a fork, is the proprietary solution developed by AWS, but at the end of the day, it's more an enterprise solution. You might love it, you might hate it, but at the end, it's still a 2 out of 4. Again, you start the instance, and the instance is up there running. If you don't do any query, if you just have some peak load 2 hours a day, nothing out of the box is going to scale down the cost for you or the resources for you. And if traffic increases, well, that's something you can do, but it's not, again, out of the box. So think about, okay, you may say, okay, I'm lazy, but I want to scale vertically my instance. I can do using the API, I can use the command line, I can use SDK. How hard is that? I can do just some API call, use CloudWatch, use my own matrix, my own monitoring, have some alarms and scale it up. You know, well, either you do that, but it's quite fragile, there's many components, many variables, it might fail in different ways, or you have to scale, you just size your deployment for peak load, and usually that's not quite effective and it's quite expensive. So when you think about automation, you want a different option. Here comes option number 4, Aurora Serverless. What is Aurora Serverless? Aurora Serverless is what is called an AutoScaling configuration for Amazon. It's been there for now over 2 years. It's GA since August 2018. It's basically an endpoint without any more instance size. You don't say anymore like in the EC2 and RDS, I want an M5 extra large instance or 4 extra large instance. You basically say, I want MySQL 5.6 or 5.7. They are compatible, they're not the communication. So up to you, we'll see the problem with that in a second. Easy scaling, you define a range, you can control the range, and it scales. We'll see in a second what that means. It scales up and down according to your usage. And you pay for what you use. You pay for the amount of resources you're using. And the cool part here when we say about reusing our code, reusing our application, is that you connect to it using your TCP connection. So for example, if you develop a web application using Java and you use your JDBC driver, well, you can still use it to connect to your Aurora Serverless. So you can really reuse what you have up to a point. That's the good part. How does it work? Well, there are 1 hour presentation I reinvented explaining you how to do it. I create a section with some reference point. You can go and watch the video, but at the end of the day, there are 2 key aspects. Number 1 is you don't really care, because at the end you want something that is elastic managed by the cloud provider and that scales according to your usage. How they do it behind the scene, if they size for peak load and charge you just for when you don't use it, unlikely, but it's up to the cloud provider. Reality, what happened is there's a proxy fleet, some pre-warm capacity, and that shows you how hard it is to implement it yourself just with some API scripts and the command line, because at the end is, yes, you can scale up and down your instance, but again, then your buffer is cold, then it takes minutes, then whatever else. And behind, you have the standard Aurora storage layer. So there are 6 copies of your data in 3 different AZ. And what are the use cases for a product like this? Well, first of all, unpredictable load. If you have an application where you don't really know what you're going to use, that comes handy. That's what you want to have. That's what they say. They want to relax in the weekend without thinking if there's really a marketing campaign going on, or even worse, something that is really unexpected, some viral success or a bug or anything else. Serverless deployment, where usually you have a problem that serverless function scale quite easily horizontally, but it's pretty hard to connect to a database. We see the challenge with that with Aurora Serverless in a second. Development and test, so you don't want to have to pay the development and test machine running all the time. So you might have that it scales down, it stops, it really pause when you don't use it, then you will wake up, and in any intermittent load you have. Amazon is not the only cloud provider offering some serverless relational database. Azure as well, they did last year with Azure SQL database. And the key point, I'm not going into details, but you see in the slide, even the announcement, the very focus was on the pricing point. So it's kind of the concept of price performance optimized. And one key aspect, at least by the default configuration of Aurora Serverless, is that compared to do a failover of your database and scale it up and down with RDS or do anything in Aurora, is they don't drop the connection. Technically, your connection running, it should be transparent to your application layer. So at some point, your database scales up according to traffic. At some point, resources scale down, but running queries are not dropped. Kind of. I said before, that's why it's important to know how it works a bit. I was lying when I say you don't need to know details. Is the key sentence is the database might not be able to find a scaling point by default. You see, in a second, you can change that in the configuration. If you have long-running queries, temporary table, transaction in progress, or any table lock. So basically, at the end, what happens is the way it doesn't drop connection is basically to wait until your request is completed. If those requests don't complete and you have some nice, beautiful script that does some long-running queries to do some nice analytics, well, your database might never scale because there's no scaling point. You can change this default to the opposite, that is basically drop the connection and scale. But basically, you cannot have the best of both worlds. Either your application, hopefully, is able to reconnect to the database and handles properly lost connection, or you might not have a scaling point. You cannot have, of course, both no scaling point and no dropping connection. You might question, is this really serverless, or is it simply an auto-scaling? Well, the second interesting part of Aurora Serverless is compatible with MySQL. You can use your TCP connection, you can use the default port, you can use many things, but at the same time, you have as well a data API. What's the advantage of the data API that is called Aurora Serverless Data API and is now GA since last summer, since 1 year ago actually, is that it's much easier to manage, for example, serverless workloads, where you don't want to use a connection pool. Now you can with RDS proxy, but or application where you really need to access the data in a different way, where you don't want to be limited to your TCP connection. How you do that? This is an example in Python. It's basically quite straightforward. You connect, you provide a credential, you provide the database name, and then you perform your beautiful query and you get your response. Of course, there's some, you're not opening the connection yourself, it's transparent to you, but at the end, the response time of API is not the same as a TCP connection when the connection is open. So if you use a pool, it's not simply straightforward to say, oh, I'm going to use the API and achieve the same performances. Specs, what is there, what is not there? Well, is MySQL 5.6 and now 5.7 compatible? Compatible is not really 5.6, 5.7. Anyway, you define a range of scaling point. You can define as well an upper limit where your database is going to scale up to a limit, and you don't want to risk that it goes over a certain limit for cost reason, whatever else, for example, for test and development machine. And that range is 1 to 256. So the first thing you really need to understand is, again, you are in a single server scenario where there's an upper limit. And that 1 to 256 correspond to basically from 2 gigabyte to half a terabyte of RAM. That's more or less what you achieve with a single RDS as well. Scaled up point and scale down, it scales up one of two main characteristics happens. So the CPU is above 90% or the number of connections above, CPU above 70 and max connection above 90, and scale down at 30 CPU or 40% and 40% connection. You don't control the max connection on the RDS on the Aurora Serverless is defined by the size of for the number of the ECU. If you want to use the data endpoint, you have to enable it. And the other important thing, we say that it can pause. If you don't make any query at all, to a database, you can say it's going to pause. It's up to you to decide if you want that. Of course, it's an advantage in terms of cost, but yes, as well, the disadvantage, it might take some time to wake up on the first query. It might take up to, they say, a few seconds. Actually, I think it's 20, 30 seconds. It might be perfectly okay for certain scenario like test development. It might be not okay in production scenario where you might want to have it always running, and you can achieve that either disabling that property. Remember as well that if you have some external monitoring tool, whatever it is, Percona monitoring tool or whatever else you want to use, that query your database, you might have the database never pauses because actually you are performing query. Limitation, that's the key part. We have already mentioned a few of them, but it's basically, apart from, it's quite a trend, of course, going from installing your own virtual machine on the cloud to using the most managed solution that is elastic. You lose control. The more you lose control, the more restriction you have. So for example, you have no MySQL 8. You cannot decide which minor version of MySQL 506, 507 you're going to use. You can use it only inside the VPC. That means that basically there's no public endpoint. You cannot connect to it from outside Amazon. You cannot import data from S3, something you can do from Aurora, from traditional Aurora. There's no, for example, ability many models are not there, so you cannot use auditing, for example. You don't control the MAC connection. You actually don't control most of the configuration. You can change, I think, 5 or 6 value, I think mainly related to the encoding. But for example, you cannot enable the event scheduler. So if you are using MySQL events, well, bad luck, you cannot. You have to find another solution, whatever cron jobs or whatever, probably Lambda function, schedule Lambda function. There's some delay when it sleeps, as we already said. And again, is MySQL compatible? It's pretty hard compared to Aurora to get your data out of it because you cannot create a replica outside AWS. So you cannot simply create a standard MySQL replica in another data center and say, I'm going to start from there. You have to export the data, and that is a bit more challenging. We say the execution time is transparent, but up to a point. It might take up to 1 minute before a failover takes place and the instance is available for another scale up. There's as well a cooldown period in terms of like to avoid that the database keep changing. When it scales up, it cannot scale down for 15 minutes. But if we go back to our full requirement, we can say probably that yes, with Bailey limitation, including kind of vendor lock-in as well, up to a certain point, you have achieved the 4 out of 4. But remember, what's one of the really important aspects to remember? There are many use cases, medium-sized, small-sized database where we really benefit, but it's still a scale up and down of your database. It's not a globally distributed database. It's not a multi-master. It's not DynamoDB or other solution that help you deploy in multiple regions or have multiple access points. Is just a single instance doing a vertical scale. So if you want scaled out, there's no major replica. It's not distributed wise. There's no automatic sharding transparent to the user. Want to close just with a tweet from that is quite on the point. It's AutoScaling can convert some performance bug-driven downtime to large builds. So yes, one of the benefits of a serverless approach is of AutoScaling elastic databases, of course, that if you introduce a bug in your application, whatever is on the SQL itself, like a missing index or a bad performing query or an application bug that triggers that, you might scale up a lot your cost. Of course, at the same time, you might gain time to fix that bug. Yeah, there's up to a point. There are certain badly written queries and certain issues that are so bad that there's no AutoScaling is going to save you. With that one, thank you. Here are some resources that I try to collect where you can get more information, where I get some information on this talk. And you can find all of them as well on my website. With that one, thank you, and I'm available for questions.